I'm going to start now and say my name is Kati Clemens. If you don't know me, I'm the coordinator of Learning Technology Accelerator Project, and today we have a very special key webinar on AI in education. First, we're going to hear from the European Commission Head of Interactive Technologies Unit, Rihanna. I don't know how to pronounce her last name, but Schwichinger Ladak or so. She has unfortunately could not make it today at this hour, so we have recorded her message. It's about 8 minutes long, so you can watch it. Let's watch Rihanna now.
Oh, okay. So hello everybody. As you know, my name is Kati Clemens and I am the coordinator of Learning Technology Accelerator Project. And today I have got a special guest from the European Commission. Rihanna, why don't you introduce yourself and give your short introduction to today's webinar.
Thank you, Kati. Hello, good morning, everyone. My name is Rihanna Schwininger-Ladak, and I'm the head of the unit Interactive Technologies, Digital for Culture and Education at the European Commission, the Directorate General responsible for Communications Network, Content and Technology. Thank you, Kati and Fabrizio, for inviting me to open this LEA webinar on AI in education. LEA is a project, I don't know if I should say LEA or LEA.
LEA is what we say.
Yeah. The project funded by my department as well as the predecessor, EMAI. So I will take this opportunity to talk about the work we do at the European Commission to support the uptake of AI and other emerging new technologies in education. So AI has strong political visibility in the past months, and I think that is increasing, given its increasing impact on the economy, on society, on the future labor markets, and of course on the competence requirements for the future labor markets. And the future is like now, it is happening now.
Yeah.
So what does it mean for education? Now, very quickly, education, as you may know, may not know, is the exclusive competence of member states, which means that member states can decide what they want to implement, how they want to support education. So the role of the Commission is really to encourage cooperation by supporting and complementing the actions of member states, and also to nudge them to adapt their education systems and the curricula to the requirements of this digital age. So for AI in education, it means for us two big strands of one is to support the uptake of AI and other new technologies for quality and inclusive education and learning. And two, to help address the skills gap, which is an important one. So for the first one, which is support the uptake of AI and other emerging technologies in education, we need to invest in research and innovation to encourage solutions that improve education and learning through these new technologies. We all know that high quality education is vital for boosting growth and innovation and for keeping up with the levels of well-being that we have in our Western societies. So it is crucial for us that the education sector keeps up with the digital transformation which is happening overall in other parts of the economy and society. And schools need to maybe rethink the way the classroom methods are and the pedagogies and what kind of means and method they use to make teaching and learning more engaging, more effective. And for this, technologies bring many opportunities. So we know, because we all believe in AI, in the merits of AI, that it's very promising, that it will generate insights on learning, on how learning happens. It can change the way the learning is assessed. It may reorganize classrooms. It can increase the efficiency of teachers and the efficiency of the learning process. And also on the pedagogical sides, the rapid advances in natural language processing and AI-based human-machine interfaces can also generate new pedagogical possibilities. So a lot of opportunities for AI in education. So right now, we are at the commission level, we are at the end of a program, which is Horizon 2020, as you all know. So we have been supporting projects on innovative solutions using technologies, a bit less AI, but more in the years to come, to develop skills and competencies. We have been supporting projects that develop tutoring systems, immersive learning environments, interactive online labs, multimedia channels, open cloud-based educational resources. So we have a number of projects dealing with that. We are now reflecting on the priorities for the new program, which is Horizon Europe, where we know that we will need to support further the research, the innovation, and the uptake of activities such as artificial intelligence. Because we know we need smart solutions on all levels of education with novel ways to organize, structure, and enrich learning and teaching. That will also allow the personalization of the learning experience and how really to best respond to the user's needs and abilities. Now, before closing, I just would like also to say a quick word about the training possibilities that we have in terms of skills gap. So the Commission is also very active in terms of really trying to bridge the skills gap. And we know there is an urgent need for upskilling and reskilling. So we have a number of actions for AI dedicated master's program for on-the-job training and traineeships for young people, such as the digital opportunity traineeship, or a stronger focus on AI for the Marie Curie actions. So I really also invite you to go and see what there is there. One of our ambitions is also to establish a European program for industrially oriented PhDs in AI, and to keep this way researchers in Europe after the PhD, because the brain drain is an important issue. So overall, what we are thinking, so the European Commission has proposed for the next generations of programs that will cover 2021, 2027, a number of programs. So first of all, we have Horizon Europe, which is going to be the continuation of H2020, where we will have overall, of course, 15 billion in the digital and industry cluster, which includes AI as the key activity. Secondly, we are going to have a new program, which is called the Digital Europe program, which is about deploying capacities and capabilities. And in the Digital Europe program, we are going to have 2.5 billion for AI, focusing on testing and experimentation facilities and data platform. And Digital Europe program will also have a skills part, an advanced skills part, which is very important, where AI is also going to be an important part of addressing the skills gap. And that this part will really look into providing training courses and job placements. So I really invite you also to really keep an eye on the developments of these two programs. So in a short, a lot of things happening on AI. It's really a priority for the EU. We are right now devising our course of action for 2027. And so, as I said, I really invite you to follow the developments, the calls that are going to be published next year in 20 and in 21. So that was my short message. And with this, I wish you a good webinar, and I will hand over to Fabrizio. Thank you.
Thank you so much for this, Rihanna.
We often have recorded experts and take questions afterwards. But today our main focus is with Fabrizio Cardinali, who is the CEO of Knowhedge, but also the regular AI and blockchain experts of emerging technologies from European Commission, or working with European Commission. And we have the privilege of getting Fabrizio here to talk live with you guys for a little bit longer webinar than our usual. So there's a lot of activities happening in the next, I would say, 1 hour or so, and we'll take some questions and link up to the work of LEA after Fabrizio has given his introduction.
Okay, so thank you everybody for being here, and what we will be doing today is passing more or less, I understand, 40 minutes talking about learning machines, which is the topic under which I would summarize and present both robots and machine learning concepts and human beings, which de facto are, I would say, the best learning machine today. And we will actually go a little bit between the story and history of the relation between men and machines. And I will hopefully close with 7 tips to help the people in the audience, which I assume being educators, learning technologies, managers, on how they can actually take the correct distance from robots and resize them and keep the humans in the loop in an age where machine learning, intelligence, and supremacy is getting into place. First thing is, why should I be talking about this? So what is, in a very difficult market, what is the title that I have to talk about this? Well, first of all, I was one of the first degrees in Europe in the what many call the second spring of artificial intelligence, which was the one of logic programming, of languages like Prolog, Lisp machines, which were all about semantics and explicit AI, explaining reasoning. And also there was a time of hardware dedicated to do that, like Lisp machines or other very costly machines. And it seems that in those ages, and I'm talking about more or less the 90s, it seems that AI and expert systems, which was the more commercial implementation of AI in those days, could actually solve any problem in a very generic and general viewpoint. It actually turned out that in less than a couple of years, I would say 3 or 4 years in the US, 5 or 6 in Europe, this spring turned out to be an autumn, because actually general AI wasn't deliverable. And although expert systems started to do very good things in the industry, there was no such thing as a generical machine able to do a lot of things and too many things that were originally thought of. So off I went to actually engage more in learning technologies, which I actually was working on learning per se in the first applications of AI, both for medicine and for educational purposes inside the interactive intelligent tutoring systems in the Delta program. And I got passionate on learning technologies for human beings. And then I actually started, since the 90s up to, I would say, yesterday, doing a lot of development in learning technologies. Some of you might recall some of the companies that I founded in the field, especially Junti Labs and Harvest Road Digital Repository and Exact Learning LCMS are quite famous in the learning technology space. And those were the time where people were at the center of technologies, and we were using social, mobile, cloud, and big data to actually train people. And there was no such thing as machine intelligence around in those early days. But since we recently, I would say some 5 or 6 years ago, we entered the third wave of AI, which somebody has called the third spring of AI, I actually decided to go back to my original first training and interest, which was artificial intelligence. And starting to focus more again on machine learning, AI, edge computing, but also new things like IoT and blockchain, which are surely giving to AI a new spin into the market. Hopefully making this third way of AI the one which will actually make it to be very effective and very useful also for education. But since I'm an entrepreneur, I kept on doing even startups. And today we have, together with some colleagues, 4 or 5 startups which are working in AI for supporting human beings, from financial markets, which is Wavener, to industrial markets like SmartTrack or SkillAware and others, which we are engaged in. But the main one that I'm engaged in, which is the one which is presenting today, is this Knowhedge technology, which is actually a consulting boutique firm of people around Europe, which have come together to design new collaborative scenarios of man-machine collaboration. actually trying to keep men within the loop. So it's not all about just technology, but actually how can human beings use such technology for enhancing their performances, their safety, and above all, their delivery onto the workspace. And we're doing this mostly with HR departments, which are now willing to add an R to their acronym, not only HRM, but HRM, which R stands for robotics. And under the convincement that also HR people should start talking about robotic resources in their workforces. So that's more or less what we're talking about today. Now, the main point to start off with is actually how near we are to the point where technology will be so disruptive to actually take the place of human beings. There's a very interesting book which is from Ray Kurzweil, which is quite famous for being a futurologist, innovator and technologist, and also head of engineering in Google, which recently took again the term of singularity, which is was originally introduced by von Neumann, the inventor of the architecture of computers as we know them today, in the 50s, and stated a couple of years ago that we are more or less not 10 years to go to the point where singularity will take place and machine intelligence will go ahead of human intelligence. Now, you would expect these statements from a futurologist, and it's not the matter that Ray said this, which should create concern, but it's actually that a couple of years ago, there was a newspaper, actually the Times magazine front page, which brought together with Ray also Stephen Hawking, the never forgotten Stephen, together with other two big players of the market like Bill Gates and Elon Musk, to say that actually the 2029 deadline was more or less feasible and realistic. And it was 80% positive messaging, but there was also a lot of concerns. And the one who better expressed the concerns was actually Nick Ostrom, which was the less famous of the five, and he is actually the director of the Institute of Humanities at Oxford Universities. And he came out with a statement that we're building a technological Disneyland. The pity is that maybe we will have no children to visit the Disneyland, human children to visit the Disneyland in the next future. And this was a very provocative statement. We actually also have a blog running on our website where you could also contribute once we will give you the slides at the end of the webinar on this very, let's say, provocative statement. It actually seems that things are quite in the perspective, true in the perspective of singularity, that things could happen very soon. And Kurzweil introduced three main reasons why this should actually be accelerating. The first one was actually that we are in an age of exponential doubling. Now we all know the Moore law, where things have actually been doubling in terms of capacity of storing information, processing information, shipping information over the web over the last more or less 50 years. Every year having a doubling of performance and with chipsets getting smaller and smaller and cheaper and cheaper. Now, the point is that doesn't make so clear what exponentially means, because you think it's hidden in boxes. You're just using technology, and you don't really realize the pace at which all this is actually happening. Kurzweil, in his book, started a very nice story about the myth of the invention of chessboard. Which was brought to an emperor in China or India. It's not clear actually where this happened, but the fact was that the emperor was the king was so happy about this new invention that he told the inventor that he could actually request what he wanted as a prize. And the inventor, which was actually a mathematician, decided that he would have asked just for a rice. A piece of rice on the first square of the chessboard, and he was asking that it should have been doubling its quantity every other square of the chessboard. And the king, which wasn't a mathematician, actually approved that, thinking that it was quite easy to satisfy the request of the poor man. He actually then realized that when he started doubling in the first squares, things started to become quite heavy. And actually, when things started to get into the second part of the chessboard, things got out of control. We're talking of millions and millions of rice and something which you would need the overall world covered by rice plants to feed in. The story ended that the poor man actually got his head cut off because the emperor couldn't satisfy the request. And still today, if you go in India near Delhi, you have people offering you rice bowls according to this legend. Now, this means one specific point that Kurzweil wanted to make very clear in his book, is that as soon as you start doubling for 10, 20, 30 years, something in technology, it still is controllable by human beings. But as soon as you get in the second half of the chessboard, things get huge. They just double every year and get out of control. And there's also another law which he introduced in his book, which is the law of accelerating returns, which is very, very in favor of the fact that singularity is quite near, which is the fact that, as you see here, at some point, the Moore law started to flatten. So it wasn't possible any longer to put more chips on computers and more transistors inside chips. And in order to keep the pace of innovation, which is the business of all the large manufacturers and de facto the business of all the large players in computer science today, they had to come out with new technology and new inventions to keep the doubling rate. So this is exactly the law of doubling that was in the book of Kurzweil, which is very interesting, meaning that technology actually starts to get so sophisticated that it actually starts to get better and better in order to keep a pace of doubling every year. And so if normal things like, let's say, cloud, mobile, or other technologies get flattened or get it to be a commodity, new things will come out which will just burst out and keep the doubling rate. And that's exactly where we are today, because things like IoT, blockchain, AI, edge computing might already have been there ages ago, but they've been rediscovered recently just to keep the pace of innovation and doubling. And this means that things are really going out of control because there's a lot of exponential conversions and innovation, and a lot of things are starting to mix up across borders and across sectors. And it's actually a time where it can be very interesting times because you can reinvent not only the technology, but actually even a lot of the fields to which technology is actually applied. Now, this is all about the future, but the best way that we might have to think about the future is to look to the past. As Carl Sagan, which maybe if some of you are Americans or maybe from the Nordics, is a very well-known futurist which did the world's most seen TV series in the 80s, where he actually took a calendar of the past and mapped the history of mankind on a 365 days calendar to discover that the most interesting things actually happened the last couple of days of December, when humans come to Earth, and everything happens actually in the last week of December. Now, we use a similar paradox in Knowhedge when we do consultancy into large executives, where we actually have taken a much smaller time machine, which is the 24-hour clock. And we have mapped the 10 years which are here to the 2029 prediction of Kurzweil of being the singularity into the clock. And we found out that that is just 7 minutes to midnight. So to better understand these final 7 minutes to midnight, which, by the way, is the same topic which the balloting of the atomic scientist is the same timing where the atomic scientist of the US has posed the Armageddon clock, which was invented soon after the Second World War to say how near we are to the nuclear holocaust. And they also started 7 minutes, and this clock is now every year reposition backwards and forwards, and it happened that we are more or less a couple of minutes to midnight this year, so very close to the nuclear Armageddon. But not to be that catastrophic, we actually positioned the 7 minutes to midnight also on the clock. But rather than looking only forwards, we are actually looking into the past. So the first thing is that if we actually look even before midnight, which is time zero, which is the birth of Christ, the Anno Domini, actually not many things happened before then, actually, for let's say, the relation of man with machine. There's a very nice book from Adrian Mayer that I would suggest, which actually goes back to the mythology of robotic ancient artifacts. And there are examples of Talos in Crete, which was done by Vulcan to actually defend the island. There are histories in the Jewish tradition of Golem and many others. But it's actually it's more an intent to actually think of how you could create life with craft, which is the origin of biotechnology, which actually goes back to those early days. But nothing interesting, I would say, happened actually before midnight, if not on the philosophical, psychological level, where a lot of philosophers of ancient Greek started to question about the human consciousness and how association of ideas could actually create knowledge, and how knowledge was actually achieved via learning, with the Summa Maxima of Socrates stating that he was the most acknowledged man in ancient Greek simply because he knew nothing. And this starts to be very interesting even in the early days of the rebirth of artificial intelligence, because there is a big risk of biased information. So as Nathan Collins pointed out in a very recent article, he said that just as we learn our biases from the world around us, machines will learn their biases from us. So it's quite useful to know that even the origins of mankind knowledge was based on the fact that we should start from scratch many times when we start teaching to artifacts and to things, especially to smart machines. But as I said, really little happened in the first day before midnight. But even very little happens actually on the day of the 24 hours that we have mapped Anno Domini to 2030 in this clock. And nothing happens more or less up to the Renaissance, where more or less a lot of things just explode. They explode thanks to the fact that, as Mr. Franz Johnson, the professor of Harvard, states, it was just the possibility of creating the perfect knowledge storm. And that was possible simply because innovation in the Renaissance time wasn't that linear. So there was no dogmatic difference between the separation between literature, maths, medicine, science. Actually, things were much more mingled up. And it happened to result that having a mingle of innovation, which is typically linear in a single domain, and cross domain, actually made a burst of creativity in Renaissance. And that's where really people started to look into machines and actually how to make machines both to augment their performances. So very famous is the Leonardo da Vinci machines, which were all oriented towards creating of artifacts which could empower both the art of war, but also the art of actually performance in the sky, like the Icarus flight. But even more interesting in those days, what is very relevant to AI today is that eventually the origin of anatomy took place with this guy, which was named Vesalius for the then fashion of talking Latin, but he was actually from Brussels. And he was the first man to actually start creating atlas of anatomy, dissecting cadavers. And he was the one which by first stated that the brain was the center of the ideas against the Aristotelian belief up to then that it actually was the heart to be the center of the body. So that's where things started off, I would say, in the study of alternatives to the human intelligence, and actually starting from how the human actually intelligence kicks off, learns, and acquires knowledge. But then things went back into a more mechanicistic approach, and I would say that up to the first industrial revolution, which happens more or less at 9 p.m. in this 24-hour clock, you don't have a lot of things happening again in terms of intelligent machines. You have very smart machines like the spinning mule, which was invented by Compton in 9:12 p.m. more or less, so near to midnight. But the fact the guy didn't patent the solution, even if it was actually the trigger of the very flourishing cottage industry in North UK, where it actually started off an industry of creating cotton from the materials coming from the US and from the Americas. Actually, not US yet in those days. But things even more accelerated with the advent of machines which were able to capture power, like the James Watt steam engine. And there is a very nice book from Jan Morris, which actually, if you see here, makes every burst of social development, including well-being and population rise, literature and knowledge rise, actually all reside on the based on the invention of the steam engine. And he actually says that everything bursted out with the capability of machines to capture energy, but also to actually start making war with them, which was obviously a negative aspect, but also the ability to process information with actually those machines in those days. Because actually that's where all the first industrial revolution started off, by bringing people into the towns, where now we're equipped with a large engine to automate the spinning mules. Workforces started to organize themselves into trades, and media was actually invented to support the messaging across these new trade unions and people, with the invention of the rotative printing, which happened more or less at 7 past 10 towards midnight. When it comes to more specific robotic automation, the approach was very mechanicistic. Very famous for this period is the Mechanical Turk, which rallied the European courts, starting from the one in Schönbrunn Palace for Maria Theresa of Austria, where this inventor, Kempelen, actually invented a fake automata which was playing chess. It actually was all a set of wheels and guinders where an internal player was able to move and win against aristocrats. And the books are, in those days, the information was full of even very important people like Napoleon and others being defeated by the Mechanical Turk. But this actually wasn't that smart. It was more smart in the invention of doing something fake to then win these challenges. But when I would say that the new approach to artificial rebuilding of human beings really kicks off is actually with the second industrial revolution, where we actually have electricity coming to market, with the big war between Edison and Westinghouse, one in favor of direct current after they invented the bulb more or less in around 10:40 p.m. in the afternoon. So more or less 19 minutes to midnight. And Westinghouse was instead in favor of alternate current, which was needed to bring current in a very long distance, which was actually a market request, so that people and venture entrepreneurs could actually move the factories outside the polluted town and put them inside the countries. So even if the Edison invention was very smart, it was actually Westinghouse who did the right choice. And he was helped for doing this actually by Tesla, which is also very famous today, but was the guy between the decentralized distribution mechanics behind Edison invention. The War of Currents, which is actually the naming of a very nice film describing this in the cinema shows in these days, lasted literally just 5 minutes in a 24-hour clock. So from 10:15 to 10:20 p.m. And at the end, Edison realized that he did the wrong invention, switched to Westinghouse AC standard, and started buying all the electricity industries around, and becoming very, very popular and very, very rich by doing that. The invention of electricity and the means of transportation of electricity is very, very important, because it's actually the way that also influenced a lot the thinking about knowledge, learning, and human intelligence in total. So that's where actually a first approach to constructionism, connectionism, cognitivism that you find described here started off, which were influencing all the psychological, pedagogical, and even technical development thereafter. That was, on paper, on theory, on humanistic theories like, again, knowledge, learning, and psychology. But there was a guy which was a little bit more advanced than the other ones, which was Hermann Ebbinghaus, which more or less around 952 came out with a theory of recall and short-term and long-term memory, which is very popular today in performance support. That actually took more than 100 years actually to be implemented in technology, and in a 24-hour clock, that means more or less 1.5 hours to make it to market in computers. The idea behind Ebbinghaus was that he was stating that memory actually flows out if you don't store it into long term, and you can do that by long term transferring information by repetition and unbiased need. So actually, if you do something when you need it, and if you continuously repeating it, it gets into your long-term memory. That's more or less the concept of GPS when you drive a car, and it's at the basis of performance support tools today. But as usual, psychological theory was far in advance from engineering and technical implementation. So the first things which came out in terms of smart machines mocked up the idea of previous behavioristic approach than the constructive one. So actually, whilst Henry Ford was inventing the car production machine, Marconi wireless communication, John Baer television, and so on, the first learning machines were very, very deterministic to some extent, behavioristic. Where actually the idea was a black box which was electrified or mechanic, but mostly more and more electrified with the invention of electricity, but things were observed outside the box without getting inside of it. So the idea was that you gave some stimuli, you recorded the output, and that was the learning machine, which was able to understand and to repurpose the stimuli to make humans learn. That was a very behavioristic approach, as I said, because the associative cognitive approach took more time to actually move to smart machines. And the first one who actually did something smarter, but it wasn't actually for an associative cognitive implementation, but it was more on the machine side, was Turing, which invented this model of a machine which was able to read an instruction set. You see it here in the unlimited infinite strip which goes through the machine, and to take some decision at the output. Now, this was a theoretical model because actually there was no such thing as an unlimited strip. And what really computers needed was a memory concept. And that's where the architecture of von Neumann was very, very important, because it actually was needed to back up the information. And von Neumann invented what is still today the average architecture of a computer, which has got a memory where you actually fetch information and you store information, and you also can fetch and run instruction sets. But interestingly enough, in the same age also came the advent of the perceptron, which was the very first neural net, which was invented in 1958, so less than an hour to midnight, actually 51 minutes to midnight, which was mocking up not a black box, actually entered the box and started mocking up the concept of neurons. And what this box was all about was about a machine which wasn't actually running programs, but was actually recreating connections which had a weight, which was done by valves and electrodes, and the possibility to actually mechanically do multiplications of values at the input to generate the output. So by showing things like figures or outlines, this was able to classify and differentiate one view from the other with a camera and attached to it. But it was a very, very simplistic approach, and despite the very positive reaction that the New York Times gave it, where actually it was declared that the machine invented by Rosenblatt would have been able to walk, talk, see, write, reproduce itself, and be conscious of its existence, as you read there, actually the system proved to be able only to do linear classification, so separating vision of things which are either class A or class B, and there's no, I would say, non-linearity possible with this machine. And anyhow, this invention was very useful because it kicked off what was the, I would say, the first conference on AI, which took place at 52 minutes to midnight in 1956, where the still recognized fathers of artificial intelligence, namely Marvin Minsky, John McCarthy, and others, came together to start the field of artificial intelligence, and with a very generic assertion that the conference would have dealt with every aspect of learning or any other future of intelligence which could have been described and done by a machine to actually be implemented. Now, that was a very important date because not only built on the experiences of von Neumann, more traditional architecture, which then led to logical AI, but also kick-started the big developments in neural nets, which started with the perceptron and then actually became artificial neural networks as we know today. So from there on, it's been a continuum of rise and depth inside investments. Actually, as you see here at the kickoff of the conference, there was a hype and a lot of investments from ministries of defense and ministries of labor, and it was the first spring and summer of AI. But then it resulted that the perceptron was very, very basic, and it could actually not implement anything tougher than a linear emulation of and classification. So at that point, it became the first winter or dark age of AI, because everything suddenly stopped. But luckily enough, as I said, the two areas of logic AI and neuron AI was anyhow going on the back. And the first one who came out again was the logic AI. So the concept that rather than doing it with neural networks, it was a von Neumann-like architecture which was used to do logics. So semantic reasoning, knowledge bases, expert systems, that's where actually I got the green. So that was the second hype. And it was an age where expert systems were developed for everything. It actually seemed that special machines like Lisp machines could come to market and cost a lot of thousands of dollars to implement. But again, things just faded out because generic AI wasn't possible. Expert systems were very, very interesting, but too costly to implement. And there were things like the web. And thereafter, mobile and social came into place, and that went into, again, another winter. But what happened is that more or less at some stage, in order to keep that doubling possibility of the more low that I was saying before, that people rediscovered neural networks, starting to add memory to them, eventually with backward propagation, and adding more layers in order to have them emulate not only linear classification, but also non-linearities and much more complex situations. And that's more or less, if you see the stripe here at the end, the blossom of the third spring of AI, which brings us to more or less 2016. Why is 2016 that important? Because more or less, it's the age where we actually had the logical AI winning Garry Kasparov. So Big Blue did a computer which was Deep Blue, done with logics AI, so with programming logics, not with neural nets, and it actually defeated Kasparov in a very famous match, which happened in 1997, so less than 28 minutes to midnight. Thereafter, we also had more or less arriving to date. To date, we are 7 minutes to midnight. And what's happening today is that we are now getting back into artificial intelligence led by neural networks. So big companies like big companies like Google, Facebook, and the others actually started investing in architectural neural networks, and finally came out with a company which is AlphaGo, which defeated the world player leader of Go, which is a Chinese game, awarding to the computer a 10 Dan recognition, which is the maximum recognition that you can have in this game. Now, to end the story, I just want to summarize that this is a lengthy presentation on the clock, but it's very important to understand the past to appreciate the future. And that's where today we can start understanding much better than this. The age that we are entering is going to be exponential. In terms of smart machines, it's going to be combinatorial, so that it's going to affect any market and any actually field that it's going to touch. It's also going to be holistic, meaning that it's not just going to be either technology, computer, or structures to be influenced by this, but also people and processes. And last but not least, it will need to be regulated, because as far as we don't understand it, we actually have to be sure actually of what is the power and what is the level of integration that these machines will have in our workplace. Just going on from here, things are actually going exponentially fast, as we just said before. And if there is one field where we can see how fast they are going, is actually in cyber robotics. Because, and you could say, well, we don't deal with robots. We've got software, we've got cleric work, so we're not actually in the factory. But there's a very important paradox from another futurologist and robotist, which is Moravec, which actually Moravec stated that if you can actually make a computer or a machine walk, run, see, recognize, and smell, that's going to be insanely harder than making it translate language, play chess, make calculus, and even make mind reasoning, because it's actually much more difficult to make the combination of sensors, reasoning, and execution that makes a robot alive. To see what happened over the last 10 years of robotics, it's very nice to see this presentation from Honda in 2006, where they were launching their computer named Asimov, in memory of Asimov, and it was a general meeting in Tokyo where people were simply all astonished by the walking capability of this robot. All the press was writing, firing news about how advances were reached in robotics, when this computer started climbing a stair, which is apparently a very simple task for a human being. And that's where robotics in 2006 demonstrated completely the limits that it was in those days. It actually started walking up in a very steady position without any big problems, cheering to the press and to the people in the audience, when then suddenly something happened and it stumbled down. And you had people rushing to cover the scene and begging newspapers how to report on what happened, and so on. Now, that's more or less in 2006. Now, if you want to see what it is to be in 2016 in robotics, so 10 years after, and that's more or less 7 minutes in the clock that we were saying before, these are all videos that you can find online from Boston Dynamics. Boston Dynamics is quite popular because it was bought by Google 5 years ago, but then eventually broke up because they were very integralistic of what a robot should be able to do. In their perspective, it should be walking, running, saving lives, and so on. Google bought it for doing stand-up computers to aid families by cooking, cleaning the house, and so on. So they eventually broke up and exited Google some years ago. Today we have even very cheap robots which reassemble the idea of Google of robotics, like the Baxter, which went bankrupt actually a couple of months ago, so meaning that there still is not that massive market for this, or even professional robots like the ABB one, which cost more or less less than a yearly worker fee. So with $40,000-$50,000 you can buy these computers and make them do astonishing things. So, and that is not only for robotics, it's for hardware. It's also for softbots and chatbots, or even for robotic process automation. Here you have softbots, which are actually doing the work of a clerk in a university for student enrollments. And you see that what is actually done by a human being, and it's a very repetitive task, is done by a chatbot and softbot at one fraction of the time. Meaning that, as I said, if you can make a computer or a robot do what you saw before, it's quite easy to make it do data entry, process information, chat with you, and so on. And these are the sorts of works that you now see emerging on the marketplace. So here you have robots serving serving at a bar. You can see this is at the recent, this is the ABB computer robot at the recent Frankfurt Industry Messe. And this is actually, so you can't see it well here, but it's maybe this one. I think we can actually try to make it play. Well, this is Amazon with all its internal warehouse management systems done with robotized moving computers and robots and so on. So this is the level that robotics, hardware and software, is actually reaching. And I would say that the estimation that 10 years after these guys will actually start competing with mankind is quite feasible. And that's not only what I think, but it's actually what a lot of ministries and a lot of policymakers are thinking. For example, the US Ministry of Labor estimates that 65% of students in education today are being trained on things which will never happen at work and doing new jobs. Even more astonishing, Oxford University recently quoted that 57% of jobs will not be there in the next future. And so on. Now, somebody might say, well, this already happened in agriculture, where we had 80% of population engaged during the 19th century, which has been reduced to 2% today. Well, it's not that true, the similarity, because first of all, this will be much more pervasive. So there will not be another market like the agricultural people moved into the industry. Now, this will be much more holistic geographically, but also task-wise. So anything will be affected by these capabilities. And secondly important is that this is going to merge with a big demographic changes. So we have people like myself, which are the baby boom generation, which were raised on the Sputnik effect of the conquering of the moon after the speech of Kennedy and the Rice Stadium and so on. And we have the millennials, which are just entering from their social mobile background into this market. And this will be a very big crew change in the next, in the current, it is actually a very big crew change in the actual years. And so the personas that will be dealing with this change will not have the same background than the one which are ruling the industry today. So we need to train them with different capabilities, typically with strategy management, with talent management, with process management, and so on. So presumably it's not going to be the best taught or the smartest student that will survive these changes, but the ones which will understand the drift and change in the market, develop new competencies and skills, and be able to adapt to the new places and new jobs which will be out there. So if this doesn't happen, we do have a problem. Key is actually policy making. So since we are in a European Commission webinar, it's going to be crucial much more than policies about immigrants and or basic income scheme, which is affecting a lot of policies at nationalistic levels, like in Italy, where I'm actually everybody's talking about immigrants and national income schemes. Very few are talking about the fact that these, even giving income, basic income might be useless, because there's a very well-known effect in insurances, which is named Peltzman effect, that people with driving belts actually don't save their lives more, simply because they drive faster. So the idea of giving a basic income scheme is not automatically meaning that people will upskill. They might just relax more. So the idea is that mostly there needs strategy towards AI and embracing AI. Eastern countries, Southeastern, like South Korea, Japan, and Asian markets have started. The US is starting. In Europe, we are still quite behind, with only UK and France having some steady strategy. And the numbers of patents and new codes in AI is very, very limited. So that ends more or less the main part of the presentation. Now I want to go into some 7 suggestions that I give to you who actually are procurers, are buyers of technology, are users of technology, and eventually are educators. We usually do this in a couple of days workshop where we deepen all the technical aspects and also the interdisciplinary aspects of our suggestions. I'll do this very fast here just to give you a minimum sense of what we are talking about. So the 7 tips are about, first of all, managing innovation. So the first thing is that you might be used in managing change. There's a lot of literature about the Kubler-Ross curve of how you can actually manage disaffection of new topics, new jobs, new things to be learned, and you know how to tackle with resistance, anger, letting go, and you do know that after some time things get better and they get adopted. So, but if you start thinking of AI and machine intelligence in this way, it might not be enough, because things are much more steep and the curve is much more marked than this one. It's actually very similar to this one. This is a curve that Masahiro Mori, which was a roboticist in Japan in the 70s, actually designed some time ago, calling the deep dive that you get when you have very advanced robotics the uncanny valley, meaning that people are not confident in entering a zone where computers and automatons are so similar to man, and they try to stay before. So even Masahiro said in a recent interview to Wired, why the hell should we get into the uncanny valley? Shouldn't we just stop at the level of the Honda Asimo robot that you saw before? Now, their answer is clear. Since it's a big business and it's a big scientific development trend, and the law of doubling and of exponential development that we saw before will get us into the uncanny valley. Actually, we are already here. And so the only way you have is to actually understand innovation and start climbing out of the uncanny valley into the plateau of technology adoption. And to do this, you need to manage innovation in the right way. Obviously, you need to have to solve your knowledge gap. So the first thing is that you should run workshops, conferences, engage your people and your students on these new topics. You should obviously wait for them, because even if technologies are changing exponentially, people dramatically are late, more loser and slow to learn. But also, and mostly, if you want to then transfer this to the ground of your organization, being a school, an institute, or a government, the problem is that those organizations are still very slow, even slower. They are logarithmically in the adoption of innovation. So you need to face these 3 gaps and equip yourself before you travel into the uncanny valley in the right way. The second way is how to actually travel fair and well, which is open innovation. So open innovation is a new trend invented by University of California, or named by University of California, where the idea was not to do things alone, but to actually engage startups, external consultants, innovators, and to run contests so that you can do co-creation, minimization of the risks, cost-effective research and development. And I think Kathy will talk about PCP, pre-commercial procurement, which is the European and governmental answer to open innovation. And that is one means. The other means that you could do it by running contests, calling startups. I've been doing more than 50 startups contests over the last couple of years since I founded Knowhedge and started investing in startups. But none of them have dealt with learning technologies innovation. So a message here is that you should run contests or embrace PCP for doing that for innovation in schools for AI. The third messaging is about doing experience, not only academic research. So you need to be very practical and use AI on the field, actually not only for training or applying and recalling additional training, but in the 5 moments of learning, going down the curve to decision taking, managing performances actually on projects and cockpits and on the field. That's where AI is going to be very, very effective, and it can complement traditional learning in a very effective way. The other thing is to use AI and smart machines, maybe not where they are good at, actually where they are good at and not where they are not good at. So this is the towards singularity curve of how human and machine skills will balance. You will actually pass from things which are manual, repetitive, very well done by computers, and less by humans, and critical decisional cognitive skills much more in the hands of humans. And luckily, machines will have much more difficulty to get at that level. So if you can balance this right, and putting soft bots in your offices and taking off the robot which is in you, like clerical work, repetition work, correcting essays, or enrolling students, that's something that robots and soft bots can do very well. And keeping the emotional intelligence side on the human side, and the automation intelligence and the repetitive intelligence on the robotic side. Things will surely get more interesting, but as it starts, robotic process automation is exactly all about doing clerical works automatically. And there's a lot of solutions out there, also in this KPMG study, that you can access to start doing this. Then, obviously, you will need to foster human skills. There will be 3 main skills, as McKinsey says here, that will be very relevant in the future. The first thing is understanding technology. The second is also being more human, with more empathic skills, more human intelligence, and empathy towards your colleagues. These are all things that the computers will do much worse than humans, and on which we still have a very strong winning edge. So fostering these 21st century skills will be very important, and creating curricula based on this is going to be fundamentally important. So, for example, universities of Cambridge Pacier curricula, which is all about problem solving, analysis, creative thinking, interpretation, evaluation, reasoning, is going to be very, very key to actually keep the winning edge on the machines. Then you will need to foster creativity and not detect only talent, but detect genius. If there is one thing that Marconi, Einstein, Jobs, and Ma, the CEO of Alibaba, had in common, is that none of them were recognized as talents at their first labor talk and or at their school admittance interviews. They were actually felt as below the average. So actually, that is not enough. If we want to compete, we will need to rediscover genius, a little bit like Renaissance time, and creativity be the center of our thoughts. There's a lot of consultants in the US which have already understood this, and they are reaching back to the Medici effect and to the Leonardo's time to understand how you actually create creativity and you manage creativity inside workplaces and also educational settings. And it's mostly about putting people together with different backgrounds and interests. And last but not least, I would like to close with a video from the single software that I would want to show, which is the Grid, which is a company in California which I work with and which has taken my idea of a Sputnik effect to actually build a very effective promo video based on Kennedy's speech and presenting their solution. And this is very important because it brings us to the Sputnik effect. So the fact that people are very good at upskilling and reskilling themselves. This is the film Hidden Figures, which maybe a lot of you have seen, where these ladies were called computers because they were actually very good at computing, and they actually sent the man on the moon. And then came Big Blue, the IBM computer, but these ladies didn't just disenchant or go off of the market. They actually trained themselves and they started to become computer managers. And this is a very good film, and it's presumably a very good messaging to close, is that the humankind is very, very good in actually building skill sets and requalifying themselves in the quest of challenging against the machine. Now, I don't know if you hear the video. It's something that is very valuable to be seen on the web. You can find it on YouTube. And it's about this, it's a rap which uses the word of Kennedy, but it's all about the fact that we are facing a new Sputnik moment. And this app is able to actually, it's a micro-learning technology which uses, like Netflix, AI to suggest books and videos or other things to actually give you skills and credits. They are actually micro-credits to the extent that they are recognized. They are actually provided by multi-source, and the AI is actually using for proposing you things coming from journals, televisions, YouTube. And the idea is that skills shouldn't only come from the Fortune 50 most important companies or most accredited universities, but it can actually come by AI giving you the right information at the right moment. Okay, I think that's more or less it. You have my information here for those who actually want to contact me, and we will also be giving the slides where you will be able eventually to also go into the blog about Disneyland with no children, where I would be more than intrigued to hear from you your ideas and your feedbacks about this approach. Kathy, I hand it over back to you. I hope we are okay with the timing. And if there are any questions, I'll just close the presentation and be available for answer if there is any question to be answered.
Yeah, thank you so much. This was very inspirational. I think it was very good for our audience to hear this kind of oversight of where has this AI hype come from, and also to see that it, you know, has been going in these cycles, and that we have been actually for a very long time now already been talking about AI, and even though we say that, you know, it's moved so rapidly right now, if you're thinking about it from the very longer perspective, lots of these ideas and behind the algorithms have already existed for a longer time. So
Sure.
But let's see, do we have any questions? I know that this has been very long, so thank you everybody for your time and so on. But if you have some questions, you can ask in the chat box below. I can start by asking you a question about what is happening in the classrooms with your knowledge at the moment, because as you know, in LEA's state-of-the-art analysis, we were looking at the solutions right now, and we came to the conclusion that the AI in many of the classroom-related solutions is very basic. So it is still, obviously, we are still in the weak AI level. We have not reached beyond the uncanny valley. We have not gone to machine consciousness. Maybe we never will. So my question is this: that have you recognized any deep learning? I mean, you gave an example at the end of this recommendation Netflix style system.
Yeah.
But are there other good examples that you know? Because I think that they are not in the mainstream systems yet. The AI hasn't
Absolutely.
reached.
Yeah, absolutely, Katie. As you know, when I was visiting Learning Technologies UK on behalf of LEA at the beginning of the year, it's actually an event that I visit over the last, I would say, 10 years. So it's a very good thermometer to see what's happening there. And I was quite astonished by the lack of use of IoT, blockchain, and AI in educational technologies. So they really are, I would say, a decade away from what is feasible today and what other sectors are embracing. But there are side runners or outrunners which are doing it alone, even against, I would say, the more orthodox institutional academic pace, where they are just filling the gap. And, you know, there's been examples, for example, in Angola for the oil industry, or even in the US for the PC industry with Cisco, where if there is not an offering from the academy at the right moment with the right tools, industry will just step in and do it on alone. So the fact is that if we are not building a curricula for AI and for blockchain and for this sort of things in the next future, we will have private organizations doing this because it's actually dramatically needed. And obviously they will be using the tools that they are preaching to walk their way. So very, very little streamlined implementation. Everybody's talking about AI, frankly, but while VR and augmented reality has made it to the marketplace, so there's a lot of offerings, AI is more or less as VR was 3 or 4 years ago. Everybody talks about it because they need to do it, but nobody really knows what it is. Even interviewing the stands, they were using if then else rather than checkboxes, rather than traditional algos on talking that it was AI, but it wasn't AI to such a large extent.
Yes, well, exactly. What is AI? I mean, if you're starting from Turing's ideas, for example, I think the definitions of the different levels of AI is still discussed in the academia. And what they agree is that we have not reached the strong level yet, but not necessarily like deep learning, for example, is defined as something that was not yet, that was not able to do with the less powerful computers. I think I was looking at the kind of definitions on deep learning, and it doesn't.
Yeah. I would say that we have these two big trends of logical AI and mechanicistic or geometrical AI, as I would call the deep learning stuff. The deep learning is astonishingly good where you have waveforms like images or language translation, but it's not explaining itself. You need tons and tons of data, and it's a little bit like an alchemy, the return they give. So there's no really explicitation of the reasoning. And sectors like medicine, industry, and obviously education can't stand with a black box approach. So not only this is regulated by GDPR, but it's also regulated by common good sense. So we need an AI which is more explainable, and presumably going back to the early days of perceptron or classification, where there were alternative algorithms which were very effective to explain rules and reasoning, and adding it up even with expert systems, now much more powerful, is going to be presumably the best solution for education, in my perspective.
Okay. And from the buying technology point of view, if you are a school's budget manager or a procurer, What would you invest in the next 5 years?
Absolutely in joining LEA. And I'm not saying this because you are the kind host, but because PCP, which is the public version of Open Innovation Startup Contest, is the way to go. So PCP philosophy and contractual obligation is that things must not exist on the market. They must be ready to be there, and then you can follow it with PPI, Public Procurement of Innovation, once they get out. But really the transition, PCP is a transition from a very good TRL 6 or 7 level of things which are there, fully doable, and to start doing them for their challenge that the procurer requests. So the idea of teaming up in schools, academies, vocational training, getting PCP funds from the Commission, and doing challenges to solve the fact of adding intelligence to the learning technologies, which is dramatically absent in many cases, is a very good way to go, and definitely one to embrace.
Yeah, yes. We have gone on so long today, so I'm not going to go into more detail at the moment for innovation procurement, which is obviously LEA's focus. But if you are not familiar with this, I suggest that you go and re-watch webinar number 1 from our website, where Wallin talks about what is innovation procurement, what is PCP, what is PPI. We also have this section called opportunities, where we are saying what projects we are doing, what you can join in. Also in the future, we are going to be applying together with LEA Network future projects to those calls which Rihanna was mentioning at the start of this webinar. So the whole point of LEA project is to bring all of us together and see who is interested in joining, who is interested in what, and doing some common demand, because obviously together we are stronger in Europe than if everybody's doing their individual thing. So there is that. Do we have any last questions for Fabrizio? I know we've gone way long today. You can also send them later to his email address or to coordinator@learntechaccelerator.eu, which is our address. Was this clear for everybody? Difficult to understand, easy to follow? What did you think? If there is no questions, I'm going to thank you for today. Thank you for lasting for a very long marathon webinar. And thank you, Fabrizio, for taking your time to prepare us for this topic. I think it was very interesting and gave us some tools on how to really grasp what is happening for us. And the recording is going to be online within 1 week from now. We're going to have Mikko edit it. Could be sooner than that, but that's the timeline. We can also share the slides as Fabrizio mentioned earlier. Okay, great. Thank you, everybody. In 2 weeks' time, we have a company visitor in our webinar series, so maybe see you then.